The human body is a living library, but the most important story it tells isn't written in books. It's written in the very pigment of your cells. For centuries, we've been told that skin color is a marker of identity, a badge of heritage, or even a source of division. But recent studies have uncovered a truth that is far more haunting and even beautiful. Your skin color isn't a random roll of the genetic dice. It is quite literally a biological precision tool. It is a masterpiece of engineering that took 200,000 years to perfect. It is the record of a brutal, high-stakes war between two of the most essential nutrients in your body and the sun itself. If you have very fair skin, your ancestors survived a world where the sun was a vanishing ghost. If your skin is deep ebony, your ancestors conquered environments where the sun was a relentless, lethal forge. Today, we're going beyond the surface. From the ghostly extremes of the poles to the deep, dark, ebony biological shields of Africa, we're going to explore how a few microscopic grains of pigment, melanin, determined who lived, who died, and how humanity managed to colonize every corner of this planet, irrespective of immense challenges by nature on the skin. So, this is the secret history of your skin, and by the end of this video, you will never look at the color of your skin or that of some other person the same way again, because you will get to fully understand what your unique skin color really says about you. But before we continue, permit me welcome you to the channel, and yes, we know curiosity brought you here. This space satisfies that curiosity by exploring the strange, forgotten, misunderstood, and deeply human tales found in history, science, and the lives of real people. If this sounds like something you'd enjoy, then consider subscribing to the channel for regular videos that will always leave you nodding your head after watching. Now let's move on to the story. Let's start at the edge of the spectrum. Picture the windy shores of Ireland, the icy fjords of Scandinavia, and the misty gray regions around the Baltic Sea. In these places, you'll find the most extreme examples of very pale skin. This skin is often called milky or see-through. If you have this skin type, you've probably noticed the blue and purple veins visible just under the surface. To someone just looking, this might seem like something is missing. But from an evolutionary point of view, it's a highly specialized way for the body to adapt. The amount of melanin in this skin has been reduced to the lowest possible level needed for cells to work properly. And the reason for this is as brutal as it is simple. It's about staying alive in a world with very little sunlight. For most of human history, survival meant one thing: vitamin D. We often think of it as just another supplement, but for our ancestors, it was the difference between a healthy life and a slow, agonizing death. Vitamin D is the sunshine vitamin. Your body can't just eat it in sufficient quantities, it has to manufacture it. And it uses UVB radiation from the sun as the catalyst. In places like Northern Europe, the sun is so weak during the winter months that it barely provides any UVB at all. UVB stands for ultraviolet B radiation, which is a high-energy, invisible component of sunlight. It plays a huge role in triggering vitamin D production. UVB is strongest during midday in summer. So, if these populations had kept the dark skin of their African ancestors, they wouldn't have been able to make enough vitamin D. This would have led to rickets, a disease that softens bones, causes legs to bow, and twists spines. Before modern medicine, rickets was deadly, particularly for women who could have children, as their pelvic bones would deform, making childbirth impossible. Research into ancient DNA has even revealed a surprising fact. The extreme lightness of European skin developed incredibly quickly, within just 5,000 to 10,000 years. This is very fast when you compare to other evolutionary changes. As people moved into Europe after the last ice age, those with slightly lighter skin had stronger bones and healthier children. In only a few hundred generations, the dark-skinned people who first settled the north were replaced by the light-skinned groups we see today. It was a struggle for survival, where the key to success was the ability to absorb every bit of sunlight that touched the skin. That's it for the people of the north. Moving south, we see a shift in skin tones, with people having light golden brown complexions in areas like the Mediterranean, North Africa, and South Asia. This fascinating middle ground experiences distinct seasons. Winters are generally mild but can be cloudy, while summers are extremely hot with powerful UV rays. Researchers studying vitamin D production have discovered that this particular skin tone represents the ideal balance developed through human evolution. Think of melanin like a set of blinds on a window. If the blinds are always closed, as it is the case with dark skin, you don't get enough light in the winter. If the blinds are always open, as in very fair skin, you get blinded by the glare in the summer. Golden brown skin, however, is a dynamic and a clever system. In summer, this skin has enough melanin to act like a shield. It protects your body's folate, an important B vitamin we'll discuss later, and stops painful sunburns. Likewise, when autumn arrives and the sun's rays become weaker, the skin doesn't stay dark. Instead, the amount of melanin lessens, effectively opening the blinds to let in as much of the limited sunlight as possible. It is a living, breathing response to the Earth's tilt. Scientists studying Mediterranean populations discovered that these individuals maintain stable vitamin D levels across a wider range of environmental conditions than almost any other group on Earth. They are the generalists of the human race, adapted for a world that refuses to stay the same. Now, let's talk about one of the most genetically complex and misunderstood skin tones: olive. You'll find this phenotype across southern Europe, the Middle East, and even high in the Andes Mountains. Olive skin is famous for its neutral base, that subtle greenish, yellow, or gray undertone that seems to change depending on whether you're standing in the sun or the shade. But why the green tint? Why the shifting colors? Genetic studies show that olive skin is often the result of crossroads populations. These are regions where, for thousands of years, different groups of humans met, traded, and intermarried. It is a beautiful mosaic of DNA. But the function of olive skin is what's truly extraordinary. Researchers have suggested that these neutral undertones create a kind of optical camouflage. In bright, direct sunlight, olive skin appears darker, absorbing more UV rays. In the shade or under overcast skies, it takes on a lighter, more translucent quality. This isn't just an aesthetic quirk, it's a functional adaptation. By appearing to adjust with ambient light levels, olive skin optimizes the two most important chemical reactions in human biology: the production of vitamin D and the protection of folate. Scientists have found that people with olive skin are remarkably environmentally stable. Whether they are in a sun-drenched desert or a cloudy mountain pass, their internal chemistry stays remarkably consistent. It is the ultimate all-terrain skin. Moving further into Eastern Europe, West Asia, and parts of Latin America, we find warm beige skin. This skin type is common in the Great Plains and central regions of continents. Here, the difficulty isn't just about weak or strong sun, it's about the extreme shift between the two. If you have warm beige skin, your ancestors lived in areas that experienced months of dim, sunless winters, followed by summers where the sun felt incredibly intense. To survive these conditions, the body developed a defense mechanism called inducible pigmentation. We often call this tanning, but that word doesn't fully capture its importance. For someone with warm beige skin, a tan is a very fast and efficient building project. When the first spring sun rays hit the skin, the DNA inside the cells sends out an urgent message. It senses damage from UV light and immediately tells the melanocytes to produce new melanin. This skin type is made to change its appearance. In winter, it loses its pigment to prevent a lack of vitamin D. This was a serious problem, as archaeologists have found skeletons of medieval Europeans with bones so soft they looked like wax. But as soon as the sun returns, the skin quickly becomes protected. But what's the downside of this skin type? Well, it burns easily before its protective layer fully forms. This is a risk taken for survival, like saying, I will risk getting burned in April to make sure I survive the harshness of December. This shows the daring choices our ancestors made to settle the Northern Hemisphere. Now, take that strategy and push it to the limit, and you get the fair, light-skinned people, primarily found in Central and Northern Europe. This phenotype is the ultimate photon hunter. In these regions, the sun hangs low on the horizon. Even at noon in the summer, the UV rays have to travel through so much atmosphere that they lose most of their punch. Scientists studying these populations discovered something staggering. Fair light skin allows approximately 5 times more UV penetration than the darkest skin types. Think about that. In a world where light is a rare resource, fair skin is a high-efficiency solar panel. It doesn't matter if it's overcast. It doesn't matter if the day only lasts 6 hours. This skin is so sensitive that it can kickstart vitamin D production using the barest hint of light. To a person with deep ebony skin, this fair skin looks incredibly vulnerable, and it is. In the tropics, this skin would be riddled with cancer and folate deficiency within years. While in the north, the risk of sunburn was historically zero. There was no sun to burn you. The adaptation was optimized for scarcity, not abundance. The vulnerability to the sun wasn't a flaw. It was a trade-off that allowed our ancestors to survive in places where, biologically speaking, humans had no business living. Now, let's travel to the cradle of humanity, East Africa, particularly the regions inhabited by Nilotic groups near the equator. Here we find deep ebony skin, the absolute pinnacle of melanin production. This isn't just dark skin. This is an incredible technological achievement of evolution. Research from the National Institutes of Health shows that this skin contains such high concentrations of eumelanin, the dark, protective form of melanin, that it blocks approximately 95% of harmful UV radiation. Imagine wearing a permanent SPF 50+ sunscreen that never washes off, never needs reapplication, and is perfectly integrated into your DNA. That is what deep ebony skin is. But for a long time, scientists were puzzled. They thought the main reason for this was to prevent skin cancer. But here's the cold, hard truth of evolution. Natural selection doesn't care about cancer. Why? Because skin cancer usually kills you after you've already had children. Evolution only cares about what happens before you reproduce. So why this shield? In the year 2000, a groundbreaking study revealed the missing link. It wasn't about cancer, it was about folate. Folate is a B vitamin that is absolutely essential for life. It is the fuel for DNA synthesis. If a man's folate levels drop, his sperm count plummets. If a pregnant woman's folate levels drop, the baby can develop devastating neural tube defects like spina bifida. And guess what destroys folate? The sun. UV radiation penetrates the skin and literally breaks down the folate circulating in your blood vessels. In the blazing sun of the equator, a human with light skin would become infertile and lose their offspring within a single generation. Deep ebony skin evolved as a biological vault to protect the gold of human life, our DNA. So, in all essence, it is a masterpiece of reproductive preservation. As we move toward West Africa and parts of South Asia, we see rich dark brown tones. In these areas, sunlight is still very strong, but it changes a bit more. This might be because of long monsoon seasons with many cloudy months, or because the land provides more shade. The Smithsonian's Human Origins program describes this skin type as a flexible guardian. The amount of melanin in this skin is a little less than in very dark skin, but there's a good reason for this. Studies from 2022 reveal that the way melanin is arranged in these skin tones is different. In the darkest skin, melanin is tightly packed into small clumps. However, in rich dark brown skin, these clumps are spread out a bit more. This allows about 20% more sunlight to enter the skin. But why would someone want more sunlight to get through? To help their body make vitamin D during the rainy season? This shows how evolution makes subtle adjustments. It's like nature saying, I need to protect important nutrients, but I also need to make sure vitamin D is produced during the 3 months of heavy clouds. It's a careful balance between two different needs. These groups of people demonstrate how adaptable humans are in places that offer both great resources and dangers. Finally, let's look at mahogany brown skin, found across Melanesia and parts of South Asia. This tone is striking because of its reddish or copper undertones. These aren't just for show. Scientists analyzing these phenotypes have found a unique mix of eumelanin, black/brown, and pheomelanin, red/yellow. This combination creates a skin type that blocks about 70 to 80% of UV rays, significantly less than the ebony shield, but vastly more than the fair-skinned solar panels. This skin type evolved in tropical and subtropical zones where the sun is pulsed. Think of islands where the weather changes by the hour. Researchers discovered that mahogany skin has an ultra-fast tanning response. Because the baseline contains more pheomelanin, the skin can pivot its production toward the darker eumelanin almost instantly when the sun breaks through the clouds. It is real-time adaptation. Your body immediately recognizes the threat of UV-damaged DNA and sends a signal to the melanocytes. Construction crew, get to work. Within hours, the skin's protective value increases. It is a living sensor system. At this point, you might be thinking, we are so different. But here is the most mind-blowing part of the story, the part that ties every human on this planet together. Recent studies of our genes have uncovered a surprising truth. Every person, no matter their skin color, has about the same number of cells that make pigment. If you have the fairest skin in Sweden and your friend has the darkest skin in South Sudan, you both have the same equipment. You both have the same number of pigment-producing factories in your skin. The only difference, the only reason we look distinct, is how these factories are set up. A study from 2023 discovered that the wide range of human skin tones comes down to just a few specific gene differences. These genes control three things: how active the factories are, how much are they working, how the pigment is packaged. Are they making large shipping containers of pigment or small envelopes of pigment? How the pigment is spread out. Are the containers sent to the surface in a thick layer or scattered? In a nutshell, we all share the same basic biological plan. But we are simply adjusted to different amounts of sunlight. So what does your skin color really say about you? It says that you are a survivor. It says that your ancestors were masters of adaptation. It says that your body is perfectly tuned to a specific relationship with the sun, a relationship that was forged in the fire of natural selection. If this video made you see the skin color a little differently, make sure you hit the like button. And if you enjoy uncovering the hidden science behind everyday things, subscribe to Curiosity Brought You Here and turn on notifications so you never miss what we explore next. Now I want to hear from you. What's something ordinary that you've always wondered about? Drop it in the comments. It might just become our next video. Until next time, stay curious. After all, curiosity brought you here.